All right, everybody. So we're looking at Regents Review number 2, Astronomy. Let's look at number 1. So number 1 says, list the following astronomical features in order of relative size from smallest to largest. All right. So the smallest is first the planet, right? Jupiter. All right. And we know that Jupiter is part of our solar system, right? With 8 planets. And the biggest object in our solar system is the sun. Okay. And so the next biggest object is the combination of our solar system. All right. So our solar system is next. All right. And we know that there are many, many solar systems in one galaxy. Milky Way galaxy. And last, there are billions of galaxies in the universe. All right. You could also look at fact number 7, right? And it mentions it right here. Which evidence best supports the Big Bang Theory? So let's take a look at fact 8. All right, let's take a look at fact 8. And so the Big Bang Theory focuses on the fact that the universe began with a big explosion. And fact 8b says evidence of the Big Bang Theory is cosmic microwave background radiation. All right. And so therefore that focuses on choice 2. All right. And that is just something that you need to know. All right. All right, number 3, galaxies are classified based on their shape. What is the shape of the Milky Way galaxy when viewed from directly above? So once again, this is not a earth science reference tables questions. This is simply content questions, something that we just need to know. If you look at 9b, it says right here that solar system is located on one of the outer arms of our spiral Milky Way galaxy. And so the correct answer is spiral galaxy. That is the shape of the galaxy that we are in. And our solar system is part of the Milky Way galaxy. All right, number 4. Number 4 says, which process combines lighter elements into heavier elements and produces energy within the sun and other stars? So if we take a look at fact 9c, all right, if we take a look at fact 9c, it says our sun and all stars produce light energy by nuclear fusion of hydrogen, right? Of nuclear fusion of hydrogen. And so the correct answer is fusion. And so we know the lighter elements are hydrogen, and they combine lighter elements, hydrogen, into heavier elements. What are these heavier elements? Helium. So remember, during the process of nuclear fusion, we're combining hydrogen atoms, right, to make helium, all right, during the process of nuclear fusion. All right, number 5. So number 5 says, which star has a surface temperature most similar to the surface temperature of Alpha Centauri? Polaris, Betelgeuse, Procyon B, and Sirius. So let's, oh, sorry. So let's take a look at our reference tables. What page, everybody, we're looking at? Page 15. All right. So we're looking at page 15, and we're looking at the question, right? Which star has the surface temperature most similar to the star of Alpha Centauri. So I'm going to find Alpha Centauri, which is right here. Oops. It is right here. And I'm going to click in red. I'm going to choose red, right? And I'm going to circle the four options that they gave us, which would have the same temperature, okay? So Polaris, Betelgeuse, Procyon B, and Sirius. So Polaris is here, Betelgeuse is here, Procyon B is here, and Sirius is here, right? Remember, surface temperature I see is right here. So therefore, if they're on the same vertical line, right, then they have a similar temperature. So Alpha Centauri's temperature is right here. And I gotta see, I know my line's a little bit crooked, but the one that has the most similar temperature is going to be Polaris. Is going to be Polaris. And so that's why the correct answer is going to be choice 1. Number 6, base your answers to questions 6 and 8 on the passage below and on your knowledge of earth science. And so the reading is about cosmic microwave background radiation. So make sure you're taking time to actually read through the paragraph. Don't just skip directly to the question. Number 6, scientists infer that the universe began approximately, all right? And so this is a fact that you just need to know. If you see fact 8A, it says the universe began with a big explosion, the Big Bang, about 13.7 billion years ago. All right. And so the correct answer is going to be choice 4. Sometimes there may be questions that will state for the answer to be 13.6, or they'll say a little over 13 billion years ago. All are acceptable. All right, number 7. Which graph best shows the relationship of the size of the universe, right? Of the size of the universe to the temperature indicated by the cosmic microwave background radiation. Well, what does it say in the reading? It says right here, this radiation has been cooling as the universe has been expanding. This last sentence refers to temperature here, right? And here it talks about the universe size. So as the size of the universe is getting bigger, the temperature has been decreasing, right? It's been getting cooler. So the one that shows that as size gets bigger, right? If it's as I'm moving to the right, that means the arrow means that it's increasing in size. Temperature should be dropping as the size increasing. As I'm moving to the right, the temperature should be decreasing. And the one that shows that is choice 2. Number 8, the diagram below represents the spectral lines from the light of an element in a laboratory on Earth. All right, so the spectral lines are given. This is the spectral lines that they see on Earth, coming from the light of an element. All right. Which diagram best represents the pattern of spectral lines from the same element? So we're still talking about lines that come from the same element when observed by Edwin Hubble in the light at one of the distant galaxies. All right. Let's take a look at fact 8B. All right. So fact 8B It says a redshift of light from distant galaxy indicates galaxies are moving away and the universe is expanding. So a redshift has to be shown. And this diagram we'll see, you see the spectrum from the distant star. What is the pattern that I notice? All of the lines, same pattern, they shifted to the right. When I compare these two, right, it does look as though this one right here, the lines shifted to the right, right? If it shifts towards the infrared wavelength, then therefore that means that it is a red shift. If it shifts towards the ultraviolet, we call that a blue shift. All right. So therefore, I'm looking for the spectral lines that have the same pattern, right? Two lines close and then space, three lines spaced out. But these have to be shifted towards the right, right? For a red shift. All right, spectral lines that you see from a distant galaxy has to show a redshift. And the one that shows that is choice 3. See how the lines look? How the pattern is the same, right? The spacing is the same. The difference is that the lines just shifted to the right. That's why it's choice 3. All right, number 9. Which event occurred approximately 4.6 billion years ago? So this is a fact that we need to know. So let's look at fact 10A. All right, let's take a look at fact 10A. So it says our solar system, sun, planets, asteroids, comets, meteors formed 4.6 billion years ago when a cloud of gas and dust was pulled together due to gravity. All right, so this occurred 4.6 billion years ago. All right, which is the formation of our Earth and our solar system. You could have also used, to find the answer for this, you could have also looked at page 8 of the reference tables. All right, let's script to page 8. All right. And you'll notice these numbers represent millions of years ago, right? And 4.6 billion is the same as 4,600 million. All right, 4.6 billion is the same as 4,600 million. And look to the right, estimated time of origin of Earth and solar system. That's why the correct answer is choice 4. Number 10. Number 10 says, which two characteristics do all Jovian planets have in common? Let's read about Jovian planets real quick. Let's take a look at fact 10B. All right. And so it says terrestrial planets, the inner four are rocky and small. Jovian planets, the outer four, are gaseous and large. All right. And we're looking at page 15 of reference tables for planetary data. So let's take a look. And remember, Jovian planets are the outer four. One trick that I like to use to remember is Jovian starts with a J, so I know the first Jovian planet also starts with a J. And then it's so the last 4 planets of the solar system. So all the Jovian planets are Jupiter, Saturn, Uranus, and Neptune. All right. And let's take a look at their densities. Sorry, not densities. Let me see the question. Densities and diameters. And let's take a look at their diameters, right? All of their diameters are large, right? compared to the other planets. All their diameters are pretty big, right? So Jovian planets are big planets. And look at their densities. All of their densities are pretty low compared to the terrestrial planets given right here. Sorry, the sun is not included in that terrestrial planet. Here we go. Right, so they have pretty low densities and large equatorial diameters compared to terrestrial planets. So that's why the correct answer is choice 3. All right, number 11. Which planet takes more time to complete one rotation on its axis than to complete one revolution around the sun? So we're looking at the period of rotation, right? Period of rotation, which is on page 15 of the reference tables. And we're also looking at the category period of revolution. And these data categories are going to focus, so period of revolution, sorry. Revolution, sorry. All right. We're going to look at these two categories on page 15, and we're looking for which planet has a greater period of rotation than a period of revolution. All right. So when I go, my period of revolution is here in blue, and my period of rotation at equator is red. Period of rotation is how long it takes for the planet to do one complete spin. Period of revolution is how long it takes for the planet to do one complete revolution. So I'm looking for which one has a greater period of rotation than revolution. And the correct answer is Venus. Look at Venus. Venus has a bigger period of revolution than its period of rotation than its period of revolution. So it takes longer for it to do one complete rotation than it takes for that planet to go around the sun. That's why the correct answer is going to be choice 2. All right, number 12 says approximately 97% of Venus' atmosphere is carbon dioxide. That word should look familiar, knowing what it is. Describe how carbon dioxide contributes, sorry, to the usually high average surface temperature of Venus. All right, well, this is something that we're going to need to know. Let's go to fact 10C for our answer. We're going to go to fact 10C for our answer. So it says Venus is the hottest planet in our solar system due to the runaway greenhouse effect. Venus' atmosphere is 95% carbon dioxide, which is a greenhouse gas, which allows light to pass through, but traps heat near the surface. All right. So that's the reason why carbon dioxide contributes to the usually high average surface temperature, simply because carbon dioxide is a greenhouse gas, which allows light to pass through, but it traps heat near the surface. So it's trapping heat near the surface, which gives it that high temperature. During which northern 13, during which northern hemisphere season is Earth closest to the sun? All right, let's take a look at 11C. Let's take a look at 11C. And let's zoom in. All right, so in this diagram, we see that the Earth is closest to the sun at perihelion. All right. And what's interesting is look at the North Pole right here. What is the North Pole doing? The North Pole is facing away from the sun, right? Do we see how the North Pole is facing away from the sun? So that lets me know this season, this is the first day of winter. So that lets me know the Earth is closest to the sun actually during the winter. Now you may be saying to yourself, well, that doesn't make sense because during the winter, the northern hemisphere, that's where we get our coldest temperatures. Remember, our season is not affected by the proximity or distance of the sun. It's affected by how the Earth is tilted. If the North Pole is tilted away from the sun, it'll be winter. The North Pole is tilted towards the sun, right, to see more to receive more direct rays, then it would be summer. That's why the correct answer is winter, which will be choice 4. Number 14. Number 14 says basic answer to the following question on the diagram of the ellipse below. Calculate the eccentricity of the ellipse to the nearest thousandth. All right. So basically, you were supposed to take your ruler and you were supposed to measure two things, right? Let's look at our reference tables for the formula really quick. So the formula of eccentricity is the distance between foci divided by the length of the major axis, right? So therefore, if I took my ruler, the distance right here, this is the foci distance. That's a foci distance. What's in red, that is your major axis. And when you use your ruler to find the foci distance, you have a number divided by the major axis number. And using this formula that's given right here, right? Distance between foci divided by the length of the major axis. When you do that, you will always get an answer less than 1. And so when you do that, you get an answer of 0.333 to the best of your ability. All right. Now B says, state how the eccentricity of the given ellipse compares to the eccentricity of the orbit of Mars. Well, what is the eccentricity of Mars? When I take a look, Mars eccentricity is here, and Mars has an eccentricity of 0.093. So because eccentricity is 0.093 and the one for your ellipse is bigger, then that means that the eccentricity, right? The eccentricity, let me put it right here. The eccentricity is more elliptical, than Mars. Yep, than Mars. Now you may be saying to yourself, how is that so? Our ellipse was 0.33. Mars ellipse was 0.093. The ellipse of the given ellipse that was shown on the power problem is bigger than Mars ellipse. That means that it is more elliptical. And 15. The diagram below represents planets A and B of equal mass revolving around a star. Compared to planet A, well, keep in mind, diagram below represents planet A and B of equal mass. So A and B have the same mass. Compared to planet A, planet B has blank. Well, let's look at fact 11F. Let's take a look at fact 11F. Here we go. Let me erase this other stuff. All right. So it says the closer a planet is to the sun, the greater its gravitational attraction, and the greater its orbital velocity, and the shortest period of revolution. Right here, we see if because they both have the same mass, we can't use the mass factor, right? We can't use the mass factor. Usually it would be the more mass of the object, the stronger the gravitational attraction. But in this case, they're telling us that A and B is of equal mass. So we have to know, where's it going to be weaker? Where's it going to be stronger? It depends on the planet that is closest to the sun or farthest from the sun. So when I'm looking to see, it says planet B has a weaker gravitational attraction to the star, right? This part is correct. Okay. And a shorter period of revolution. That is incorrect. All right. We just read right here. The shorter your period of revolution is, the greater its gravitational attraction. It means the closer a planet is to the sun. So the closer the planet is to the sun, the shorter its period of revolution, which means how long it takes to go around the sun. That's why the correct answer is going to be choice 2, right? Because it's going to be weaker gravitational attraction. Planet B is right here, and the sun is right here. Planet B is farther than planet A, and because the planet is farther, it has a longer period of revolution. That means it takes a longer amount of time to go around the sun. That's why it's choice 2. Feel free to, thank you for watching, first of all. The rest of the questions will be placed on another video. Please don't forget to like, share, and subscribe, and have a wonderful, blessed day. Till next time, peace, everybody.